But when viewed close up, astronomers know it as a seething monster with a 400-day-long heartbeat of regular pulsations. This aging star is classified as a supergiant because it has swelled up to an astonishing diameter of approximately 1 billion miles. If placed at the center of our solar system, it would reach out to the orbit of Jupiter. The star's ultimate fate is to explode as a supernova. When that eventually happens, it will be briefly visible in the daytime sky from Earth. But there are a lot of fireworks going on now before the final detonation. Astronomers using Hubble and other telescopes have deduced that the star blew off a huge piece of its visible surface in 2019. This has never before been seen on a star. Our petulant sun routinely goes through mass ejections of its outer atmosphere, the corona. But those events are orders of magnitude weaker than what was seen on Betelgeuse. The first clue came when the star mysteriously darkened in late 2019. An immense cloud of obscuring dust formed from the ejected surface as it cooled. Astronomers have now pieced together a scenario for the upheaval. And the star is still slowly recovering. The photosphere is rebuilding itself. And the interior is reverberating like a bell that has been hit with a sledgehammer, disrupting the star's normal cycle. This doesn't mean the monster star is going to explode anytime soon, but the late-life convulsions may continue to amaze astronomers. Analyzing data from NASA's Hubble Space Telescope and several other observatories, astronomers have concluded that the bright red supergiant star Betelgeuse quite literally blew its top in 2019, losing a substantial part of its visible surface and producing a gigantic surface mass ejection, SME. This is something never before seen in a normal star's behavior. Our Sun routinely blows off parts of its tenuous outer atmosphere, the corona, in an event known as a coronal mass ejection, CME. The amount of mass loss significantly affects their fate. However, Betelgeuse's surprisingly petulant behavior is not evidence the star is about to blow up anytime soon. So the mass loss event is not necessarily the signal of an imminent explosion. This includes new spectroscopic and imaging data from the Stellar Robotic Observatory, the Fred L. Whipple Observatory's Tillinghast Reflector Echelle Spectrograph, TRACE, NASA's Solar Terrestrial Relations Observatory spacecraft, Stereo A, NASA's Hubble Space Telescope, and the American Association. We are left with something going on that we don't completely understand. It's a totally new phenomenon that we can observe directly and resolve surface details with Hubble. Betelgeuse is now struggling to recover from this injury. Weighing roughly several times as much as our Moon, the fractured piece of photosphere sped off into space and cooled to form a dust cloud that blocked light from the star as seen by Earth observers. The dimming, which began in late 2019 and lasted for a few months, was easily noticeable even by backyard observers watching the star change brightness. One of the brightest stars in the sky, Betelgeuse is easily found in the right shoulder of the constellation Orion. Even more fantastic, the supergiant's 400-day pulsation rate is now gone, perhaps at least temporarily. The star's interior convection cells, which drive the regular pulsation, may be sloshing around like an imbalanced washing machine tub, Dupree suggests. TRACE and Hubble spectra imply that the outer layers may be back to normal, but the surface is still bouncing like a plate of gelatin dessert as the photosphere rebuilds itself. Therefore, surface mass ejections and coronal mass ejections may be different events. Betelgeuse is now so huge now that if it replaced the Sun at the center of our solar system, its outer surface would extend past the orbit of Jupiter. NASA's Webb Space Telescope may be able to detect the ejected material in infrared light as it continues moving away from the star. Andrea K. Dupree, Klaus G. Strassmayer, Thomas Calderwood, Thomas Granser, Michael Weber, Katerina Kravchenko, Lynn D. Matthews, Miguel Montarges, James Tappan, William T. Thompson. https://ift. TT, JUFRFZ. Accessed August 11, 2022. Thanks for watching. Please subscribe my channel for more videos.